Hello everyone. In the last few classes, we had discussions on the joining process under that module number 4, and we all finished that joining process. And the next concept under module number 4 is belt drives and gear drives. So let us see what is this belt drives and gear drives, and we will go on discussing what is that belt drives and what are the different concepts under belt drives, then gear drives, and the different concepts under gear drives. Yes, before going to this discussion on belt drives, I would like to tell you one thing, that is a word called power transmission. I think you might have heard this word, that is power transmission. Transmission of power from one point to the another point, or you can say it as transmission of power from the point where it is generated to the point where it is utilized. I will give you a simple example. You can take the simple example of bicycle. In a bicycle, you will pedal that bicycle at one point, and that power will be produced at that point, and that power will be transmitted to the hub of the rear wheel, and thereby which will make the bicycle to move. Yes, power from one point, it has been transferred to other point there. And like in a bicycle, as I said, we will pedal that bicycle at one point, and then the power will be produced there, and that will be taken back to the other point, that will be taken to the other point where that will be utilized, where it will make to run the vehicle there or run the bicycle there. And there, to transmit that power, we will make use of a chain, or you can say it as chain drive. And that chain drive consists of one pulley there at the point of pedal, again one more pulley at that rear wheel, and the chain will be continuously running over those two pulleys there. And because of that chain, as it runs over those two pulleys, the power will be easily transmitted from one point to the other point. So that is a simple example for that power transmission. And for that power transmission, we have two different drives here in your syllabus. One is belt drive, another one is gear drive. We don't have any chain drive in your syllabus, so we don't want to discuss that thing. We will concentrate only on this belt drives and gear drives. So belt drive is the first concept they have mentioned. We will go with this belt drives now. So let us see what is that belt drive here. So belt drives are used to transmit the power or motion from one shaft to the other shaft by means of a thin inextensible belt running over two pulleys. So as I said that in case of chain drive also, there will be two pulleys, and there will be a chain running over those two pulleys in case of bicycle. Yes, even in case of this belt drive is used to transmit the power or motion from one shaft to another shaft by means of a thin extensible belt running over those two pulleys. You can see this simple diagram here. We have one pulley here which is mounted on this shaft, and again we have one more pulley which is mounted on this shaft here. So we will make a belt, this is the belt actually, to run over these two pulleys. And when the belt run over these two pulleys, the power will be transmitted from this motor drive to the driven pulley. This is a driver actually, driver pulley, and this is driven pulley. So that power will be transmitted from this pulley to this pulley, thereby which from this shaft to this shaft. You can see the next point there. One shaft called driving shaft receives power from the mains and transmits it to the another shaft called the driven shaft. Yes, this is the main thing, that is driver shaft, which receives the power from the mains, and then this power from this will be transmitted to this shaft. This is called as driven actually, or the driven shaft. So I think you got the idea of driving shaft and driven shaft here. Next, the pulley mounted on the driving shaft is called as driving pulley. So this is the pulley which is mounted on this driving shaft. So this pulley is called as driving pulley, while that other pulley, this is the pulley which is mounted on this driven shaft. So this will be called as driven pulley, or even you can call it as follower. So I think you got that what is driving shaft, driven shaft, driving pulley, and driven pulley. The shaft which receives the power from the mains is called as driving shaft, and a pulley which is mounted on the driving shaft is called as driving pulley. It is also called as driver. And next, the other shaft to which the power will be transmitted is called as driven shaft, and a pulley which is mounted on this driven shaft is called as driven pulley. It can also be called as a follower. So this is the one which follows this pulley, so this pulley is called as a follower. They have clearly given here, driven pulley rotates through the belt drive. This pulley will rotate through this belt which flows over this pulley. Next, The belt passing over the pulley is kept in tension so as to avoid the slip over the pulleys. Yes, the belt which will be made to run over these two pulleys, it has to be kept with high tension there. Otherwise, the slip of that belt may occur. That means the belt will come out of these two pulleys, or belt will come out of the pulley. When the belt will come out of the pulley will simply rotate, thereby which power transmission will not happen there. So in order to avoid that loss, the belt has to be kept with a tension over those two pulleys to avoid that slip over the pulleys. This helps in transmitting the power from one shaft to the other shaft. Remember that. So now let us see again what is the next important thing in case of this belt drive. So that was regarding introduction of that belt drive. Next is that material used for the belts, type of materials which will be used for the manufacturing of belts. So first, when you are choosing that material for the manufacturing of belt, that material should possess some of the properties there. Let us see which are all those. The materials used for manufacturing of belts must be strong, and it must be flexible and also durable one. So this is the main qualities that material should possess. Actually, it should be strong, flexible, and also it should be durable one. And that material should also have high coefficient of friction. So if the belt material is having that high coefficient of friction, then definitely the slip will not occur here. So that is, it will be when there is high coefficient of friction, definitely that belt doesn't come out of that pulley. So that's why they are telling that it should have some high coefficient of friction. When it is having high coefficient of friction, definitely it makes that pulleys to rotate clear properly without slipping or without coming out of that pulleys. So thereby which power transmission will take place effectively. Next, let us see which are all the belt materials used for that belt actually. One is that leather belt. You all heard about this leather belts, and this leather belt will be produced or taken from cut from the backbone of the steer hides. So this material which is used for manufacturing of this belt, that is leather, will be taken from the backbone of the steer hides. And next is cotton or fabric belts. This will be made by folding that canvas to 3 or more layers and stitching together. A strong cloth, that is the canvas, will be folding into 3 or more number of layers depending on our requirement. That strong cloth will be folded into 3 or more layers, and then that folded cloth will be stitched together. So thereby which you will obtain this cotton or fabric belt. Next, that is a rubber belt. Here in case of this rubber belt, the layer of fabric impregnated with a rubber actually. So that is, will make use of that fabric again in case of rubber belt. That layer of fabric will be impregnated with that rubber material. And next one is balata belt. This will be similar to that of rubber belt, except balata gum is used in place of rubber. That is, that in case of rubber belt, that layer of fabric will be impregnated with the rubber. Whereas in case of balata belt, this is similar to that of rubber belt, where instead of this rubber material, we'll replace that with a balata gum. Balata gum will be used here. That is, layer of fabric will be impregnated with the balata gum, and then that will be called as balata belt. So remember, these are the materials used for belt manufacturing. Leather belt cut from the backbone of steer hides. Cotton or fabric belts made by folding that strong cloth or canvas into 3 or more layers and stitching together. Then comes rubber belt, layer of fabric impregnated with the rubber. And balata belt, similar to that of rubber belt, except balata gum is used in place of rubber. So these are all the 4 different materials used for manufacturing of belts, which will be used for belt drives there, or power transmission. Next, we have types of belt drives. So this is again one of the most important thing. First, let us have the classification of belt drive, then we'll go one by one actually. There are many types of belt drives, but usually these belt drives are mainly classified into 2 types. One is open belt drive, another one is cross belt drive. So remember that classification of belt drive: open belt drives and cross belt drive. So let us see what is this open belt drive now. That is the first one. These are used to connect the 2 shafts that are parallel and rotating in the same direction. So remember that these two, this open belt drive, they are used to connect the 2 shafts that are parallel and rotating in the same direction. So you can see here, I have one shaft here, that is the driving shaft, and another shaft here, that is this driven shaft. These two shafts are parallel to one another definitely, and here with the arrow I have shown the direction of rotation. This is rotating in the clockwise direction. Similarly, this will be rotating in the clockwise direction. So the belt belt drive which is used to connect these two shafts which are parallel and rotating in the same direction, that belt drive is called as open belt drive. So it is simple to remember that belt drive used to connect the two shafts that are parallel and rotating in the same direction. That belt drive is called as open belt drive. You can see here that next the detailed explanation regarding this open belt drive. The driver pulls the belt from the lower side CD and delivers it to the upper side AB. So we have a simple notations here. We'll make use of some letters. You can see here that is a point A here. That is this is a point at which the belt is leaving this driving pulley, and point B, this is the point at which the belt is in coming contact with this driven pulley. Similarly, C is a point at which the belt is leaving this driven pulley. Point D is a point at which the belt is coming in contact with the driving pulley. So for that, you can see there we have given a simple sentence here. This driver, that is this driving shaft or this driving pulley, which can also be called as driver. This driving pulley, or you can call it as driver, will pulls the belt from the lower side. So it pulls the belt from this lower side CD. So that is the name CD. Will pulls the belt from lower side CD, and then it delivers that belt to the upper side AB. That is what they have given here. Therefore, the tension in the lower side CD will be more than the tension in that upper side AB. So the tension in this lower side will be more than that of tension in the upper side. So the lower side, because this is the lower side tension. This is that lower side and this is the upper side. The tension in the lower side will be very high when compared to tension in the upper side. The lower side, because of more tension, is known as tight side. So you can see here I have given the name tight side here. This is the lower side which is having high tension. So that's why the name tight side. Whereas the upper side, because of low tension, is known as slack side. This is that upper side, and you all know that we'll be having less tension there, and it is called as slack side. Due to lesser tension on the slack side, the belt sags due to its own weight. Yes, because of that less tension, so the belt may sag due to its own weight. So that's why we have simply, you can see there, whereas on this side it's clearly just a straight line there, whereas here you can see here this side it is somewhat some curve or some bend here. So that's why it is just the sagging of that belt actually. This is because the own weight of the belt, and one more reason is because the tension is less on the upper side. So that is that sagging of that belt may occur due to that own weight of that belt. And one more thing to remember is the tension in the lower side is very high. That's why it is called as tight side. Whereas tension in the upper side is less. So that's why it is called as slack side. And on the slack side, the belt may sag due to its own weight. So you need to remember these terms actually, which is the tight side, which is the slack side, and this is the driver, driven, or follower you can call. So, and this is regarding this open belt drive, the belt drive which is used to connect the two shafts which are parallel and rotating in same direction. Next, let us move to this cross belt drive actually. So, this cross belt drive. In the cross belt drive, you can see this is the diagram for the cross belt drive. These are used to connect the two shafts that are parallel. Again, these will be used to connect the two shafts which are in parallel but rotating in the opposite direction. So only difference you can see here. This cross belt drive used to connect the two shafts that are parallel and rotating in the opposite direction. Whereas open belt drive used to connect the two shafts which are parallel and rotating in the same direction. Whereas this cross belt drive used to connect the two shafts that are parallel and rotating in the opposite direction. So this is the driver which is rotating in clockwise direction, and this is a follower rotating in the anti-clockwise direction. So these two shafts which are parallel to one another and rotating in the opposite direction will be connected by making use of this cross belt drive. In this type, the driver pulls the belt from one side BD. You can see that there this driver pulls the belt from this side BD, and delivers it to the another side AC. So this is the side from which the driver is pulling the belt, and this is the side to which the driver is delivering that belt, that thereby which this will become tight side and this will become slack side. So that is what they will tell here. Thus the tension in the belt side BD will be more than in the belt side AC. Means the tension in this belt side BD will be more than the tension in the belt side AC. Therefore BD is called as tight side. So BD is called as tight side, whereas AC is called as slack side. This is regarding cross belt drive. So this will give you the basic introduction of belt drives. In the belt drive, the different parts of the belt drives. Next, that is materials used for the belt manufacturing of belt, and then the types of belt drive, open belt drive and cross belt drive. This is basic introduction regarding this belt drive. Next, we have one simple derivation, that is to calculate the length of that belt in the open belt drive. So let us see the derivation now. We will go for this length of belt for open belt drive. Yes, this derivation will be asked for some 10 mark. So you can see here I have taken simple open belt drive here. Yes, you all can see here, this is one pulley, that is driver pulley, and this is that another pulley, that is driven pulley, or you can call it as follower. And that belt is made, this is the belt which is running over these two pulleys, and this is the point A at which the belt is going out of the driver pulley. So this is point A, and next this is a point B at which the driver that which the belt is coming in contact with this driven pulley. Actually, sorry, this is not the B, this is the B actually. This is point B. Next again, this is point C. It's a point at which the driver pulley, sorry, this is the point at which the belt is going out of driven pulley. And point D is the point at which the belt will comes in contact with this driver pulley. So these are the 4 points. A, this is B, and this is C and D here. Remember this. Okay, fine. Next, along with that, we will take some of that angles here. First, one more before that, this is that R1, that is radius of that driver pulley, R2 radius of driven pulley here. And next, we can see there, this is that angle here, it is alpha. This is also same as that of alpha here. And similarly here, this is alpha and this is alpha here. So then the total angle, that is the angle with which the belt is in contact with the driver pulley, is pi plus of 2 alpha. That is the angle with which the belt is in contact with driver pulley is pi plus 2 alpha. Whereas here in this case, you can see there the belt that is in which is with which the belt is in the angle with which the belt is in contact with this follower is pi minus of 2 alpha. It is pi minus 2 alpha here. It is pi plus 2 alpha here, because the belt will be in contact up to this point as well as from this point, whereas here belt will come in contact with this point and it may leave at this point. So these two pi plus pi, that is 2 pi, may subtracted from this 180, whereas this pi, that is 2 pi, will be added to this 180 here. That's why 5 plus 2 alpha, whereas here it is 5 minus of 2 alpha. Next, let us see which are all the terms which will be made using this derivation for this length of open belt drive. So let us take that R1, that is radius of the larger pulley. This is the R1, that is radius of a larger pulley. Next, R2 is the radius of smaller pulley. And C, that is a center distance between the two pulleys. You can see that points that C here. This is the center distance between these two pulleys. This is the distance between these two pulleys. Next, L is total length of the belt. That is starting, if you start from length of belt to measure from this point, so the total length of the belt is from ear to ear, and ear to ear, again from ear to ear, similarly from ear to ear. This is the total length of the belt which will run over these two pulleys. Next, let us see what is L1, L2, L3. L1 is length of the belt which is in contact with larger pulley. So L1 is this one. L1 is the length of the pulley which is in contact, L1 is length of the belt which is in contact with larger pulley. And L2 is length of the belt which is in contact with smaller pulley. Yes, this is length of the belt which is in contact with smaller pulley, that is L2. And next, L3 is length of the belt which is not in contact with either of the pulley. So I think you got that idea now. If you add that L1, L2, L3, you will get the total length of the belt. So L1 is length of belt in contact with larger pulley. This one, from this point to this point, this will gives you L1, that is length of belt in contact with larger pulley. Then L2, that is from this point to this point, length of belt in contact with smaller pulley will gives you L2. And L3 is length of belt which is not in contact with either of pulley. That means you can see here, this is from A to B, this is length of belt, as well as C to D, that is from this point to this point. These two are the length of the belts which is not in contact with either of the pulley. So total length will be this L1 plus L2 plus L3. This is L3. So you got the idea now. This will gives you the L3 is the length of the belt which is not in contact with either of the pulley. So if you know all these things, then we'll go for the actual derivation now. I will write the expression for total length of the belt L. So I will give that length of the expression length of the belt as L is equal to L1 plus L2 plus L3. You already know what is L1, L2, L3. L1 is length of the belt which is in contact with larger pulley. L2 is length of the belt which is in contact with smaller pulley. L3 is length of the belt which is not in contact with either of the pulley. So next, from the diagram or from that figure, we can write the expression for L1, L2, and you can see here to calculate L1, L2 from that open belt drive, the diagram what we considered, L1 is equal to pi plus 2 phi into R1, L2 is equal to pi minus 2 phi into R2. So this angle, it has to be multiplied with that radius of the larger pulley, and this angle of contact, it has to be multiplied with the radius of the smaller pulley. L1 is equal to pi plus 2 alpha into R1, and L2 is equal to pi minus of 2 alpha into R2. So next what we need to do, that is here, so to calculate L3 is length of the belt which is not in contact with either of the pulley. That L3 has to be calculated. So for that L3, we need to do a slight modification here that I will show you in the previous diagram itself. You can see here. So I need to do a little modification, that is from this point O2, I need to draw a line, that is you can see there, that is dotted line I have written here. I need to draw a line parallel to this AB. This is the length of the belt, that is the belt AB, and I need to draw a line parallel to that AB. You can see here, yes, this is that line, dotted line which I have drawn. So that modification has to be done, that slight modification has to be done to calculate L3. So from O2, draw a line O2P parallel to that belt AB which is not in contact with either of the pulley. So that belt AB will not be in contact with either of the pulley. So for that we need to draw that line O2P parallel to that AB. Yes, here I have that diagram, I will show you here itself. You can see here. So this is that O2P, line O2P drawn parallel to this AB which is not in contact with either of the pulley. So next I will take a triangle, that is from triangle O1 O2P. O1 is the center of the driver pulley, O2 is the center of this driven pulley, and this is a point P. I will take this right angle triangle O1 O2P. So from this O1 O2P, I will write what is the expression for this O2P. Make use of the Pythagoras theorem. So O2P is equal to O1 O2 whole square minus, if you write that O2P square is equal to O1 O2 square minus O1P square, that is O1 O2 square, this is what that hypotenuse actually, and we have that O1P, that is here the adjacent side to this angle. So and again if you write this just O2P, everything will comes under this square root. I think you all know this thing. Next it can be given as this O1 O2, you all know that this is that center distance C there, O1 to O2, it is center distance C. Instead of O1 to O2 I will write that as C square minus O1P. You can see here this is O1, that is O1P, it is equal to R1 minus of R2. So R1 is this thing, that is the total that is radius of this larger pulley R1, and this is what R2, this much is R2 there, you can see that this is what R2 here, right, from here to here, that is O to B is R2, right? This O2P is same as that of this is AP here. So that is, this is also R2. So this O1P is nothing but that radius of this larger pulley R1, that is from O1 to A minus AP. AP is same as that of R2. So that's why this O1P will become R1 minus R2 whole square. Then we will multiply this numerator and denominator. We will multiplying that numerator and denominator by c square. Or here you can say it as, we will multiply this expression, that is multiply and divide this expression by c square, or even you can say it as, that is multiplying the numerator and denominator by c square. A small modification has to be done to calculate the length of belt which is not in contact with either of the pulley, and that modification is, we need to draw a line from O2 to O to P. We need to draw a line O to P parallel to this AB, and then we need to consider this right angle triangle O1 O2 P, and then we will write the expression for this O2 P. This is equal to O1 O2 whole square minus of O1 P whole square under the square root. Next we will write O1 O2 as C, and we will write this O1P as R1 minus R2. So next we will multiply and divide this term by c square. So we will write that as O2P is equal to, and everything will come under square root only. That is, it has to be this has to be multiplied with c square into again this term divided by c square. So this is the most important step. Next we will simplify this step again. It is very simple. You can see here what will happen there. So if you simplify that, you can see there this c square and this c square will get cancelled. That's why it will become 1 here. In the very next step you can see here, this will get cancelled with this c square, will become 1, and here this will come to denominator of this R1 minus R2. So that is what we are writing in the next step actually. Yes, that c square, this will get cancelled with c square, will become 1, and that c square, when it comes to denominator of this, you can, instead of writing R1 minus R2 whole square divided by c square, instead of writing that, we will write that R1 minus R2 divided by c whole square, and everything will be under square root. So let us see what is the next step now. So this can also be written as, that is O2P will be written as, that is take out this square root, will become, this will become c, and this will become 1 minus of R1 minus R2 divided by c raised to 1 by 2. I am just taking out of this, or expressing this, we will take this c square out of the square root and writing this as 1 minus of R1 minus R2 by c whole square and raised to 1 by 2. So let us see now what is next actually. Next, this is that expanding the term in the bracket using the binomial theorem and neglecting the higher powers. Yes, this is a term which is in the bracket. This has to be expand by using that binomial theorem, and again we will neglect the higher powers. So we will see what we are going to get if we expand this term which is in the bracket by binomial theorem. So 1 minus R1 minus R2 whole square raised to 1 by 2, it can be written as, by using that binomial expansion, we will write this as 1 minus of 1 by 2 R1 minus R2 by c whole square. So this is how that expression, you are going to get this expression. Next actually, so then we will substitute this value. Instead of writing this value, we will substitute this value, as the term which is in the bracket has been expanded by using binomial theorem. So equation 4 becomes, you can write this O2P is equal to c into, we will write this expression 1 minus 1 by 2 into R1 minus R2 by c whole square. So that is how your equation 4 will get changed here. Next, we got that length O2P, that is we got length of belt AB, isn't it? You can see, I will show you here. So we got that, what is the equation for O2P? O2P is the O2P same as that of AB. So this is nothing but AB, length of the belt AB, and line O2P is parallel to the length of belt AB. You all know that this is parallel to the length of belt AB. So this will be an expression for AB also. Similarly, by drawing a line from O2 parallel to CD, so we had drawn that line on this side, that is parallel to AB, and we got this expression. If you draw this line, that is O2P parallel to CD, that is towards this side, again you will get the similar expression like this. See, O2P is equal to c into 1 minus 1 by 2 R1 minus R2 by c whole square. The same expression you are going to get if you draw that line O2P parallel to CD. means you are going to get the length of CD here. So that's why you can see there we obtain the equation O2P as given above. If you draw that O2P to this towards this side, that is parallel to CD, we will get the same expression as expressed above. We will get the same expression as, once again, that is O2P like this. That means total length, that is L3, length of L3 which is not in contact with either of pulley, will be equal to 2 times of O2P. That is, it is AB plus CD. That's why it is 2 times of O2P. It is equal to 2, and write the value of our expression for O2P. O2P is nothing but C into 1 minus 1 by 2 R1 minus R2 by C whole square. The same thing I have represented here. That is O2P has to multiply by 2. 2 into C into 1 minus 1 by 2 R1 minus R2 by C whole square. So this is that length L3. We got that now. I think we got what is L1, what is L2, what is L3. L1, L2 we got that there itself in the equation number 2 and equation number 3. L1 is this pi plus 2 alpha and it has to be multiplied by R1. This is L1. And L2 is pi minus 2 alpha. It has to be multiplied by this R2. And we got the expression for L3 here. Next is we need to add this all this L1, L2, L3. That is equation number 2, equation number 3 and equation number 5 has to be substituted in equation number 1. Equation number 1, you all know that L is equal to L1 plus L2 plus L3. So it substitute that L1, L2, L3 in this expression. So L is equal to L1 I have substituted here, pi plus 2 alpha into R1. L2 is pi minus 2 alpha into R2, and L3 expression we got just now. I have substituted expression for L3. Next, I will just simplify this. I am multiplying here pi into R1, pi R1 plus 2 alpha into R1, I will write it here, pi into R2, write it here, 2 alpha R2, write that thing here, plus 2C. You just write this thing as it is, 2C into 1 minus of 1 by 2 R1 minus R2 by C whole square. Next, after that, you can see here this is a pi R1 and pi R2. Out of these two, phi is a common term. I will take that phi as a common term. If you take that phi as a common term, it will become phi into R1 plus R2. Next, here it is 2 alpha is a common term in these two, in this one and this one. Take the 2 alpha outside, it will become R1 minus R2. Next, here I will multiply this. 2C into 1, it will become 2C, and if you multiply this thing with this 2 will get cancelled, and here I will write this as, here it is C square in the denominator, whereas that 1C in the numerator. So this C will get cancelled with one of the C in the denominator. So that's why this next expression will become, our next term will become R1 minus R2 whole square divided by C. Here in the previous step it was R1 minus R2 by C whole square. So if you multiply this inside, this will be R1 minus R2 whole square divided by C. Yes, call this as equation number 6. So in this length of belt expression, this L, we got all the values here. So this C is a center distance. It can be calculated, it can be measured. R1 is length of the radius of larger pulley, can be calculated. R2 is radius of smaller pulley, can be calculated. Whereas one term unknown is, this is phi actually. This has to be calculated. Yes, yeah, sorry, not phi, this is alpha. Yes, alpha has to be calculated. Yes, this, what is alpha? So we will, to calculate that alpha, we want to take that rectangle triangle again, that O1, O2, P. From that O1, O2, P, we will write this sine alpha there. Sine alpha is equal to O1P divided by O2P. You can make use of the diagram. I think I have not pasted the diagram here. So you can go back, if you have the diagram, you can make use of that. Sine alpha is equal to O1P divided by O1, O2. So O1P it can be given as R1 minus R2. Already we made use of this expression. O1, O2 is just actually, it is center distance, that is C. So sine alpha will become R1 minus R2 divided by C, and call this as equation number 7. And here you all know that for small values of alpha, sine alpha is equal to just alpha. You all know that in the mathematics. So I will write the same thing here. So for small values of alpha, even that alpha will be very, very small values, you can look at the diagram there. So for the small values of alpha, that sine alpha will become alpha there. So then I will write that equation 7 becomes alpha is equal to R1 minus R2 divided by C, and I will call this as equation number 8. Then I will substitute this alpha value in this equation number 6, that is in place of this alpha here. So next let us see. substituting that equation number 8 in the equation number 6. So L is equal to, write this expression as it is, 5 into R1 plus R2. Next, that is 2 instead of alpha, I am substituting here R1 minus R2 divided by C, and write the next term as it is, R1 minus R2 plus 2C into R1 minus R2 whole square divided by C. The remaining equation number 6 will be substituted as it will be written as it is, except this value of alpha. Alpha value is substituted here. Next, I will simplify this. This expression or this term will be written as it is. Next, R1 minus R2 into R1 minus R2 will become R1 minus R2 whole square divided by C here, and this 2 write as it is, plus 2C here. Next, minus of R1 minus R2 whole square divided by C. And in the next step of simplification, you can see here we have 2 R1 minus R2 whole square by C. Here it is R1 minus R2 whole square by whole square by C. So here this will get subtracted from this one. So that next expression will be 5 into R1 plus R2, and if you subtract this value from this, will be written with R1 minus R2 whole square divided by C plus 2C. Yes, this is that actual expression. We will just rearrange this expression. This will be given as 2C plus 5 into R1 plus R2 plus R1 minus R2 whole square divided by C. We have just rearranged this above equation. So this expression will be used to calculate the length of the belt for an open belt drive. So this derivation you need to do. This derivation actually it's very simple. So first write that open belt drive diagram, then show all that R1, R2 and C, alpha, and show that on the driver pulley, show that 5 plus 2 alpha, on the driven pulley side 5 minus of 2 alpha, show that alpha clearly. Then go on writing all the notations used. Then write L is equal to L1 plus L2 plus L3. We all know that L1 is equal to pi plus 2 alpha into R1, whereas L2 is equal to pi minus 2 alpha into R2, whereas L3 has to be calculated. For to calculate L3, we will do a small modifications there. We will draw a line O2P parallel to that AB, then we will consider that right angle triangle, then we will get an expression there for O2P. That is length of AB we will get, and length of AB will be same as that of length of CD. So that's why that O2P has to be multiplied by 2. Then we will get the length of L3 there. Substitute L1, L2, L3 in that equation number 1, that is L. And when you substitute that, you will get almost all the term except that alpha. Alpha can again be calculated by making use of the right angle triangle O1, O2, P. If you make use of the right angle triangle, write the expression for sin alpha, then you will get as R1 minus R2 by C there. So for small values of alpha, sin alpha is equal to alpha there. Then substitute that in the equation number 6, and you will get the expression like this. Then we will simplify this, and we will get that final expression like this. Then if you rearrange this in this form, that is L is equal to 2C plus pi into R1 plus R2 plus R1 minus R2 whole square divided by C. This will be the expression used to calculate the length of the belt for an open belt drive. Even in the next class, we'll discuss about that length of the belt for cross belt drive. Remember that procedure is almost not almost it's similar to that of this length of open belt drive only, but only that sign will vary, because you all know that will be rotating in the opposite, shaft will be rotating in the opposite direction in case of cross belt drive. So that sign will vary there, but rest of the procedure or derivation, it completely remains same as that of open belt drive. Yes, that we will discuss in the next class. I think this is enough for today's class. You go through this.